Hi guys, in this class I would like to discuss about another placement oriented program. So, so this is a very tricky one, that is the prime numbers. So, so prime numbers is not actually a single program. There are actually many ways they might test your knowledge about printing a prime number. And you might wonder why prime number has to be an important one, because it is used in you know a lot of computer science practices like cryptography and network security. So calculating a prime number is actually needed for programming. So let us see what is a prime number actually is. So we can define prime number as any number n that has a factors only one and itself, and no other factors in between. So if any number can have such property, we can call it as a prime number. And what are the other numbers? These are called as composite numbers. So a composite number will have one n as well as some other n o n c and some other x. So it's gonna have more than two factors for it. So these are called composite numbers and these are prime numbers. So let us see how we can get prime numbers. So basically, since we have this information that for a given number n, it can have only one and n as its factors. So what can we do? We can iterate from a 1 to n and see how many times a number is exactly dividing this number n. So for that check, we can use this modulo operator. So let us say the variable that is iterating through is called I. So if n mod I, so if the value of n mod I is equal to 0, it means there is some value in between 1 and n that is capable of exactly dividing n. So that means I will become a factor. So I can be called as a factor. So if it is a so we have a factor in between 1 and n. It cannot be a prime number, it is a composite number. So this is how we can write the program, but instead of going from 1 to n, we're only going we're going to ignore 1. We will go from 2 till n minus 1 and check if there is any number including 2 and n minus 1, if it is capable of absolutely dividing n. We're going to break from the loop. And if we didn't break from the loop and we have completed the iteration and we haven't found any value in between 2 and n minus 1 include that is dividing n, then after coming out of the loop we can say we have found we can say the value that we got is actually a prime number. So let us try and write the isPrime function that we have defined now. So isPrime, it will take the value n, and as we discussed initially, we're going to check, and actually there is a base case. The value 1 is neither prime nor composite. It doesn't fall under any of them. So it is good to write this base case where if n is equal to 1, then we're going to return false. Remember this function is always returns boolean, right? And so what's the base case? So we are going to start for I in range. So we're going to start from 2 and we will go till n. See, in the range function, the value n is exclusive. That means we're not gonna consider the value n. It's just indicator that it will run up till n minus 1. So we have created the loop. Now, so what are we going to do? So we have the value n. So we're going to see if any value of I, if n mod I, if n mod I is equal to 0, that means this number has a factor in between 2 and itself. So we can return it's false. It's not a prime number. But if all the iterations are done and we came out of the for loop without returning, that means we have a prime number with us, so we'll be returning true. So let us see. So let's see how this works. So let us take n end of input. Let's give a prompt. And I think we can just print it, because it will be returning a boolean value, right? Okay, so let's run this code and see what happens. Okay, let us say is 1 a prime number? It says no, it's not a prime number. And is 2 a prime number? Yes, 2 is prime number. And is 10 a prime number? False, since 10 has factors 2 and 5 in between 1 and 10, so it's not. Okay, it's useful when we are trying to check for something very complex that that we cannot do by hand. So let's see, is 101101, is it a prime number? It says false. If we I try to calculate, I mean, if we try to see if the given number 101101, if it's a true or false, it's gonna be very hard. So is prime function is gonna help us in this way. So we have defined is prime function, great. But this loop, it is running for n times, and it is giving me a complexity of n. So can I reduce this complexity? Okay, let's see. Can we? Okay, let's analyze what's happening during iteration. I'm going to n. Okay, for as a case study, let's take 18 as a case study, or probably 36 probably for the case study. So 36 is not a prime number, but see why 36 is not a prime number. If we try to write all the factors of 36, you can see that it is 1 times 36 is 36, and 2 times 18 is 36, and 4 times 9 is 36, and 6 times 6 is 36. Okay, so can you see a pattern? Okay, I can see a pattern that, okay, if it can be divisible by any of the numbers in between 0 and 36 other than itself, it's either the value, so it has to be composition of two values, then one of the value has to be in the range of a 1 and the root of n. Why root of n? Because the least possible value by multiplying itself that we can get the value 36 is the root 6 itself. So you can understand that there is an optimization, but instead of iterating over all of n, we can just go till square root of n, or instead of saying square root of n, we can define it in a way that if know how to do this, we can go till square root of n. Let's import math. And let's see, square root of n. So we're gonna go till square root of n and see if this still works the same. So for 36 is to give me false. Okay, this float object cannot be interpreted as an integer. Why do we have a float object? Okay, so I think the square root function may return a floating value. So you have to make it an integer before using it in our range function. Okay, for 36, what do we get? We still get false. So instead of going till going till n, we can go till the root n and still get the same answer, and it's almost the same. Okay, so this is how each function works. But what if I need to print like a lot of prime numbers? That's okay. For to print prime numbers in a range, I need to use a for loop. For I in range n, for I in range n. Okay, I'm going to call the print function every time. For the range function, I'm going to call uh, is prime of I, and okay, I want to see if it's true or false. Yeah, but this is gonna take a lot of time, and this is not an optimal way of doing this. So instead of this, we can use something known as the sieve of Eratosthenes. What is sieve of Eratosthenes? Let's see. So a sieve of Eratosthenes is just an array, actually a Boolean array. It will be an array. It will start from index 0, 1, 2, 3. Till some n. Okay, so initially it's going to have the values all false, uh, or probably all true. Let us say all of them are false. Let us initialize each of them false. And what are you gonna do? You're gonna see if is it a prime. You're saying all of them are false. No, they are not primes. Okay, now what are you gonna do? You're gonna for each multiple of for each multiple from 2, we're gonna say they are not prime numbers because they are multiples of 2. So from 2, let us say 2 times 2 is 4. So 4 is not it's not a prime number, and similarly 6 is not a prime number. And similarly we will mark all the multiples of 2 as true. And similarly for all the multiples of 3 like 6, 9, we're going to do the same for all of them. And in the end we are going to have an array. This is a sieve of C. It will only have the value true for the values which are not prime, and a false for the values which are prime. So using this array we can just print the numbers till n just with a single iteration, instead of calling an isPrime function, which will take a complexity of root n. So for printing n numbers, the overall complexity would be order of n root n. But here it is very optimized. The mathematical complexity of it is n times log n. So log n is actually a very small number. It is almost equal to 1. So this can be described as almost similar to order of n. So this is actually the most optimal algorithm for the prime numbers. The implementation I'm going to keep it in the description, and I'll see you with another program.